All right, well, welcome back to Black Swan Outdoors. Today we are going to talk about building a dipole antenna. This is probably one of the simplest and easiest field antennas you can build. I had this in our field antenna guidebook, talk about how to build these. And so I thought I would do a demonstration on the field dipole, a Hasty dipole. Now, if you get a commercial dipole, you're going to get better wire antenna. It's going to be an overall better antenna. You're going to have better quality wire. You may have a bullum and connecting the line. And so you're going to find that you could get an all-around good use out of a commercial dipole antenna. And oftentimes many times that's recommended as the first antenna if you want to expand your radio connection. And you don't have to buy any fancy commercial antenna that you can actually make these they're pretty simple and inexpensive to build. So in order to do that, you really need just a couple pieces. First, instead of a bullum that's going to connect everything to the balanced line, you're going to use the split post connector. The split post connector is lightweight, it's highly adaptable, and it can be used for many, many different antennas. And it's pretty much the center point to our field manual, or field antenna manual that you can download. And so what we're going to do here is we're going to take two pieces of wire, as the name suggests, a dipole. There's two sides to this wire, and I'm going to cut them to the frequency that I'm going to be using. So for this demonstration, this was cut for a VHF antenna, so you can kind of get an idea of how long this is, and it's not terribly long. I'm going to cut it a little bit long. That way I can trim that antenna down if I need to tune it a little bit better. It gives me a little bit more flexibility. Also, I'm going to cut it so that I have a little bit of extra material here at the end of the antenna, so that I can attach an insulator. So what I'm going to do is cut two sides, two pieces of wire. Those lengths again is going to depend on the frequency that I'm using. I'm going to go to if I'm sticking with a particular band, I want to stick with that kind of a middle range or middle frequency within that band, so that I can get both sides of that frequency. Or if I want to, I can cut my antenna to a specific frequency that has a very specific length. And how to do that and to do those maths, again, I'm going to encourage you to pick up the book, or you could just check it out online too. So I'm going to have two lines. I like, for this dipole, I like the solid core wire, but you don't necessarily need that. You can use a lamp cord. You could use stranded wire, 13, 18, or 14 or 18 gauge. You can use speaker wire, any kind of wire really. It doesn't really matter for a Hasty antenna. It's not going to make that much of a difference in terms of performance. All antennas are a compromise, and so if you want something cheap, quick, and easy to build, that's your compromise. So, okay, so then all I need to do to build this antenna is connect both sides of this antenna to the split post connector. So I've cut the wire to length, I've stripped the wire, and I'm just going to connect it right in here. I can certainly use a ring terminal like this to make a better connection as well, especially with the stranded wire. The stranded wire is lighter, cheaper, more malleable, so it might work better in field. I kind of like this a little bit better just because it almost stands up on its own. It's just a little bit more rigid. It's just a personal preference. Now, to get this antenna to work, I need to put this up high, and that's the tricky part of the dipole, and tricky in particular in an urban area where you're running a radio, say indoors, in an attic, or in a room, or somewhere where you don't have 2 points that you can stretch this antenna out on. So I'll just use some paracord and tie it to the end of each one of these insulators, and then put it up as high as I possibly can to get the best connection. Now, I can also connect a line through these holes and suspend it through these holes, and that works perhaps the best when you're using some kind of rigid wire. In this case, this was just some fencing wire that had laying around that I'm just going to loop right in here. It's not the best connection. I could use a thinner wire for sure. That's going to be just as stiff. But this is really not anything different than what you'd see on a television set for rabbit ear antennas. And I can get this up high again through these loops, and then I'll be able to communicate. Now, you can certainly change the characteristics of your transmission by running this antenna more vertical, which is going to make it a little bit more directional. Most of the resonance is going to be off the apex or the middle of this antenna, as I believe. Correct me if I'm wrong. But you're going to get your best resonance. So if you need to make it a little bit more directional, as with many dipoles, you can just make it directional by turning it sideways and running it a little more horizontal. But this is a very good general purpose omnidirectional antenna. That's what it's built for. So if you want to get signals from all the way around you, you want to be able to both transmit and receive fairly well, the dipole works. All right, so I think that is enough for this antenna. If you've got any suggestions, comments, please put them down below, and we'll continue this series on field antennas.